Have you ever wondered how microchips, the heart of our digital devices, are made? These tiny powerhouses are the result of an intricate process that begins with pure quartz sand and ends with a chip smaller than your thumbnail, yet capable of performing billions of calculations per second. Imagine starting with a chunk of pure quartz sand. This sand gets purified and melted down to form a large silicon ingot. This ingot then gets sliced, much like a loaf of bread, into thin wafers, each about the thickness of a human hair. These wafers are then meticulously cleaned, removing every speck of dust or contaminants. Once cleaned, a thin layer of silicon dioxide grows on the surface, acting as an electrical insulator. Then comes the process of photolithography. Picture a mask with the intricate circuit design being placed over the wafer. A light-sensitive material called photoresist is applied, and ultraviolet light shines through the mask, hardening the exposed areas and leaving the unexposed areas to be washed away. Next, the silicon gets doped, a process of adding impurities to change its electrical properties. This crucial step allows for the creation of transistors, the fundamental building blocks of integrated circuits. A thin layer of metal, such as aluminum or copper, is then deposited onto the wafers to create the interconnects that join the transistors together. After this, the unwanted portions of the silicon dioxide and metal layers are etched away, revealing the underlying circuit patterns. A layer of dielectric material, such as silicon nitride, is deposited over the metal interconnects to provide insulation between them. Then, tiny holes called vias are etched or drilled to connect different layers of metal interconnects. The surface of the wafer is then planarized or flattened to ensure even deposition of subsequent layers. A protective layer is deposited over the entire chip to prevent contamination and damage, a process known as passivation. The wafer is then diced into individual chips, which are then packaged to protect them from the environment and provide electrical connections. The final step is to test the chips to ensure they meet the required specifications. Any defective chips are discarded. This entire process, from sand to silicon to sophisticated microchip, takes several weeks, requiring specialized equipment and clean room environments to maintain the high level of precision and cleanliness necessary. It's a testament to human ingenuity and technological advancement, producing the microchips that power our daily lives.